Hello, and thank you for joining today's webinar. Um, Today, we're going to be talking about the introduction to Teleport. And before we get started, um, just a reminder that this presentation will be recorded and everyone who registered will receive the recording. Also, want to let you know that if you have any questions throughout the presentation, please submit them through the Q&A section, and we will cover them at the end of the presentation. And now I'm going to hand it off to Dan.
Thank you, Anadelia. Hello, everyone. Thanks for joining us today. My name is Dan Morris, Enterprise Account Manager here at Teleport, and joining me is Jay Perez, Senior Solutions Engineer. I'm going to walk you through how Teleport is the easiest, most secure way to access your infrastructure, regardless if it's a bare metal server, cloud, container, Kubernetes cluster, Windows machine, or desktop. And then I'll turn it over to Jay to take you through a quick demonstration so you can see the product in action. Let's get started. So a little bit about Teleport. We were founded in 2015 by engineers at heart that are former Rackspace, Google, NSA alumni, with the main mission being to enable engineers to access any resource anywhere in the world. We have over 200 customers, and our core business model is open source with enterprise features and a managed cloud offering. Our difference is our cloud or access plane technology that consolidates access across all your environments into a single login via your identity provider, Okta, Active Directory, et cetera. We just raised a $110 million Series C, and we have seen adoption and partnership with organizations like NASDAQ, IBM, Samsung, Snowflake, and others. The main reason we're gaining momentum and traction is because the compute and infrastructure landscape has changed drastically, and with that has come some serious challenges. So there's been a tension between infrastructure engineering teams and security folks. Engineers want a seamless way to access the infrastructure resources they need, while security teams want to make sure those resources are protected and compliance requirements are adhered to. When we talk to our customers, they tell us that they were making a lot of unnecessary trade-offs between these teams before they found Teleport. So security in a cloud-native world is much different than it was just a few years ago. First, work from home has put pressure and essentially killed the corporate network. Second, employees at different levels of seniority need to be able to connect to their infrastructure from anywhere. And finally, infrastructure is increasingly complex. A typical customer environment that we see includes Linux and Windows servers, Kubernetes clusters, databases, and internal applications like CI/CD systems and version control systems like GitLab. In this environment, protecting modern application requires that we master 4 essential elements of infrastructure access. So the first is connectivity. If access can come from anywhere and compute can happen anywhere, we need to be able to securely connect to any resource on the planet, regardless of network boundaries. The next is authentication. We need identity-based authentication for engineers and machines so we know exactly who or what is accessing each resource. Once we know who or what is accessing, we need authorization. We need fine-grained access controls so that we can explicitly define what a human or machine can do and what they cannot do and what those privileges are and automatically enforce them. Finally, we need robust audit. Who or what accessed each resource? When was it accessed? And what was done? Without unifying these 4 elements of access, your systems will be vulnerable to attack and productivity of your teams could be compromised. So the problem is that existing solutions force trade-offs between these pillars of access. Perimeter security solutions like VPNs focus on connectivity, but leave fine-grained RBAC and audit out of the equation. So what about relying on shared credentials using Secret Vault? That still requires you to figure out remote connectivity and auditing for engineers and machine users. Not to mention shared credentials are a security liability. And finally, there's legacy PAM. While PAM solutions are usually stronger than the former on security, they tend to be bulky and slow down your engineers and don't help for machine-to-machine access. That is why Teleport is different. Our Teleport access plane consolidates the 4 essential infrastructure access capabilities that every security-conscious organization needs: connectivity, authentication, authorization, and audit. Teleport unifies access policies for engineers and machines using the same certificate-based approach. And it's not only more secure, it improves engineering and developer productivity. The Teleport access plane is zero trust, certificate-based, and it provides advanced just-in-time access workflows and gives complete visibility into access and behavior for human and machine users. We bring those capabilities deep into our infrastructure down to the protocol level. So for instance, Teleport server access gives you visibility into all SSH sessions down to the kernel level. Teleport Kubernetes access can enforce 2-factor authentication for kubectl exec commands. Teleport database access can enforce table level roles and show every query that hits your Postgres, MySQL, or MongoDB database. Teleport application access can provide a VPN replacement for internal applications like AWS Management Console, Jenkins, GitLab, Grafana, and more. And then finally, our latest edition, Teleport Desktop, gives you a modern passwordless access for all your Windows servers and desktops, including complete session recordings. Let's look at a few common use cases for Teleport. The first is simply zero trust infrastructure access. By providing an identity-aware access solution for your entire infrastructure, Teleport improves security dramatically, regardless of network boundaries. Some customers need to go beyond that and prove that their infrastructure is secure by passing an independent audit for FedRAMP, SOC 2, PCI, HIPAA, or GDPR. We have playbooks that can get you there. We also have customers coming to us saying, hey, we need to go passwordless. Teleport can replace all your secrets with short-lived certificates that are not only more secure, they improve developer experience. And then finally, customers sometimes need to modernize their privileged access management systems in a way that integrates into their distributed and DevOps-driven environments. We can help there as well. Again, Teleport is open source, and this speaks to our DNA. If you compare us with legacy solutions, you notice one key similarity in their approach as opposed to ours. They tackle the access problem by creating cumbersome enterprise solutions that cater towards checking the boxes for security or compliance and don't necessarily prioritize the end user. At Teleport, we've created a solution from the ground up with engineering, DevOps, and SREs in mind. Our founding engineers came from this world and experienced these problems firsthand. That is what makes us truly different and why being open source is so important to us. Teleport is trusted in production by customers who care about moving fast while also maintaining best-in-class security posture. Our engineering team has faced these exact challenges and have built a solution that we know works for other high-growth and security-conscious organizations. With that, I'm going to turn it over to Jay to take you through a quick demonstration.
Howdy, everybody. Jay Perez here. Like Dan mentioned earlier, I'm a solution engineer here at Teleport. Been at Teleport about 18 months, started my journey in the support team, currently on the solutions team for the last 6 months or so. I'm reporting live from the breakfast taco capital of the world, Austin, Texas. I will preface this by saying that I am Dominican American, which means I speak very fast. So if you need me to slow down, just send a message in the chat, and I promise I'll slow down and keep it to your pace. All right, let's get started. Let's start here with an architecture overview. So this is a brief overview of what Teleport's architecture looks like. Everything inside this purple box is what we consider to be a Teleport cluster. So there's two Teleport components. One is the Teleport proxy. The proxy is your entry point into your cluster. It's also how all your resources connect. The next is a Teleport auth server. The auth server is responsible for two things. One is auditing, keeping track of everything that happens in your cluster. But the most important feature of it, it's the certificate authority. So everything in Teleport gets an identity. All your resources, all your users, everything has an identity, and that's how we achieve a zero trust model. So the certificate authority is responsible for providing that identity to your users and resources. Living just outside of your cluster, we have your identity provider. So you connect any SSO you have that accepts OIDC or SAML. So this may be Okta, Google Workspace, or Azure AD to connect to your resources. Once you set this as your source of truth, Teleport is able to extrapolate the groups that users have and render comprehensive role-based access controls based on that. Currently, Teleport supports Linux servers via SSH, Windows servers via our proprietary RDP. We have Kubernetes and various databases to include MySQL, Postgres, MongoDB, Cockroach, many more. And then we also support internal web applications, something like Jenkins or Grafana. The traditional workflow for a, let's say, developer living out here, let's call it developer Devin. So when Devin logs in today, Devin will log into Teleport using your identity provider. The Teleport auth service then grants a certificate. These certificates are time-based. So once this can be configured, once that time expires, so does the access that Devin had. Additionally, these certificates have metadata, which includes all the access you require for the day. So it would say you have access to XYZ Linux servers, X application, X Kubernetes cluster, so on and so forth, as you define with your role-based access controls. But we've noticed that sometimes Devin will require production resources or needs more access than he's traditionally has. So we have a mechanism called access request. Access request allows Devin to get the temporary access she needs, and it's temporary access she needs to access any resource. And once that time to live expires, she returns back to her basic level access. We use these tools in the top to facilitate that workflow of access requests. So for example, when Devin was to request a elevated access, you could get a Slack notification, which I'll demonstrate that later on. Or you could get a Jira ticket that comes in and you could approve it through that Jira workflow. Or even we have a PagerDuty integration, which allows Devin to automatically gain the access she needs as long as she's on call or it's an active ticket. I will then move into demo and teleport itself. Let me change my screen share. All right, so here I'm logged in as Devin, as you can see in the top right corner. These are all the Linux servers Devin would have access to. And one thing you'll notice is that it's tagged with this label environment dev and dev. So Devin has access to all environment dev resources in Linux. Another thing you'll notice is that when it comes to SSH, Teleport allows you to restrict what users you can log in as. So Devin could only log in as EC2 user. So let me go ahead and SSH into the server. When you SSH into a server, it could be done via the web UI like I did here, or using your traditional CLI terminal, whichever terminal you currently use. I'm going to generate some traffic here just so I can have something to show you in the audit logs. Go ahead and close that session here. If I go to activity, under audit logs, you'll be able to see when my session started. This is when Devin first logged in to the server. If I back up a little bit, you see a certificate issued. So anytime Devin logs in, she's issued a new certificate, or anytime she requests elevated access, she'll get a new certificate. And that certificate has metadata associated to the session and all the access they have by default. But this is when the session first started. You get metadata around the server, who logged in, what user they logged in as, and also when the session ended. And the session ended, you could also play back a video recording of what transpired. The real cool thing about this, I know I said video, but it's actually text-based. So I could actually copy and paste out of here, as you can see here, copy and paste out of a session recording. Additionally, I could extract this to a file and grab for certain commands, so on and so forth. And it does play back like a video. I could pause, rewind, fast forward, just like a traditional video would. This could also be played back on the CLI if need be. Okay, so let's say Devin needs to elevate now to production level access. So we have access request, which is here. I could request access, select the role I need access for, and I could provide an optional reason. You could make this mandatory. Provide access. I'm gonna go ahead and send that request out. On my administrative side, I have this Slack channel called access request, and you'll be able to see when the request comes in. It says the request is pending. Once it's approved, you'll get a emoji that says approved. You could also get a denial, as you see here, denied. Since I'm logged in as an admin in this browser, I could just click on this link and approve it right on the spot. Approve or deny. I'm just gonna approve it for lack of saving time here. On Devin's screen, she will be able to see that the access was approved. I could then assume this role. And one thing you'll notice prominently displayed at the top is that she has access for 59 minutes. Once his time expires, Devin will return back to the basic level access she had prior. If I go to my resources now, you see that my server list has grown to include environment prod. Another thing you'll notice is that I could also log into root now. All right, I'm gonna go jump into my admin access to do the rest of the demo. I want to demonstrate something we call enhanced session recording. So as I showed you earlier, we had a video playback of a session recording out log, but it's slightly limited as you could only see the commands that were right on text. With enhanced session recording, we're leveraging what's called Berkeley packet filtering, or BPF, to get kernel level information of everything that happens within that cluster. So where this is advantageous is that we found that our customers say they have engineers that are advanced and use mostly script throughout the day. So I created this short little neat script that is going to get me my weather eventually. There we go. All right, so we get the weather here. All the script is doing, it's setting my directory colors, and then there's a curl command. So I'm gonna go ahead and show you what that looks now in the audit logs with BPF. So you see, it's a lot more data. This is when the session started. You're able to see all these entries. Every entry is a command that was run. The first few entries are from a bash RC file. The very first command I ran in my script is actually directory colors, and then this curl command. If I look at the details of this curl command, it'll show you that I ran curl as root, and this is the website actually curled. Since we are leveraging Berkeley packet filtering, we're also able to get any network connections that were initiated. As you'll be able to see here, that we allowed a connection to curl from my local IP to this web IP. And just like before, I'm able to play that session back. All right. There are many more features associated with our server access. I will leave it there so you could ask me questions later if you have something more specific. I will next jump into our other protocols. So we also support application access. This is what we consider internal applications. The advantage to using Teleport to reach these applications is that traditionally some of these apps like Grafana or Prometheus live inside a private pod or a running Docker container with private IPs that you don't expose. So our app access allows you to reach traditionally inaccessible internal apps without leveraging the VPN, and you get a secure connection all the way across. I just started up my Grafana. This Grafana is currently running inside a Kubernetes pod with internal IPs only. Another thing you'll notice here is that I'm actually logged into Grafana as my admin user. So with Teleport, we are able to leverage Java Web Tokens or HTTP headers to make this experience passwordless. So I can reach my applications all the way seamless through without having to enter a password. And you notice that's a theme with Teleport in general, that we are moving towards everything being passwordless. Another thing you can leverage with our app access is that Teleport is aware and is able to leverage IAM roles in AWS. What that means is that we could use our existing roles in AWS and map a user to that role using our console access. This works both via the CLI and the UI. So as you see here, I'm logging into my read-only, as a read-only user, into my actual AWS account where I'm hosting all my resources at the moment. Where this is advantageous is, as I showed you access requests earlier, you could use access requests to elevate somebody's access in AWS temporarily. So let's say you want to modify or fix your certificate authority within AWS using something like ACM. You could grant them that temporary access for that very sensitive work, and they'll lose that access as soon as their session expires.
Hey, Jay, we have a quick question, if you don't mind pausing for a second, from Richard. If a user needs to log into Linux VM and require a Unix profile to access data on a daily basis, does Teleport support that?
Yes. So Teleport allows you to map to an existing user, or you could use, we have a PAM integration. Our PAM integration allows you to create PAM scripts inside these Linux and Unix boxes and leverage that account creation through Teleport. So yes, both ways work.
Great.
I will jump into Kubernetes access. So Kubernetes, Kubernetes clusters, here in the UI, it tells you how to connect to these clusters. So you do need the CLI for Kubernetes. So I could do TSH status will show my current certificate and what access I currently have. So it says I have 9 hours, 25 minutes left. If I do TSH cube ls, it'll show me all my Kubernetes clusters. I'm currently logged into this EKS cluster. So Teleport remembers the last cluster you're logged into. So once I log into Teleport, Teleport actually appends my kubeconfig file with my certificate. What this means is that you don't have an indefinite kubeconfig file lying out there that could be compromised. So with Teleport, I could also just start working immediately. kubectl get pods. The very first time is a 3 to 5 second delay. After that is instantaneous. You're instantly able to connect to that cluster, and I could change context by doing kube login and GKE. And I could do kubectl get pods here, and that's how I switch context back and forth. Let me go back to EKS. I'll show you the auto login entries in a second. But what's really nice about Teleport is that we're also able to get session recordings for exec commands. So I'm going to exec into this BusyBox pod, do free ls, just get some traffic, and close out of the session. In our audit login, you're able to see all these Kubernetes requests that I've made. There should be a get pod. So I did a get pod in the default namespace in my Kubernetes cluster called EKS. And then this is when I did that exec command. I'm able to exec into that pod. Other ways to view that session recording is through the session recording tab, and it shows you EKS cluster, default namespace, BusyBox pod. Cool thing to show you is that TSH play command allows you to play back session recordings. I just got that session UUID, and I can play it back right here in the CLI. All right, the next protocol highlight would be our database access. Like I mentioned earlier, Teleport supports MongoDB, Postgres, MySQL, Microsoft SQL, and various other ones. The experience is relatively the same for all our databases. TSH DBLS will show you all the databases you have access to at the moment. At the moment, I have three Postgres ones. So I can do TSH DB connect to connect to a database, provide database name, the user, and the database in Teleport, and I'm in Postgres automatically. You could configure Teleport to speak to any client that you currently have, as long as they accept SSL certs, which most do. Could do TSHDB config, and this will show you the configuration information you need to set up these clients, and it's very seamless and fast. Let me show you the audit login for database. It's very similar to what you saw before, when the database session started, when it ended, and any query that is run. I did that du command, which in Postgres just lists all the users. It's a very long script query. And then our last protocol is desktop access. Desktop access is how we leverage RDP. Essentially, the advantage to using Teleport is that you're reducing your attack area. You could install a Teleport pod close to your domain controller, and through there, you leverage all the connections. You only have to open your RDP port to a single source. Once we connect here, I'm logging in as administrator. You'll be able to see that it's actually also a passwordless experience, just like our other protocols. Once you log in, you're able to RDP like traditionally can. You could enable or disable clipboard sharing. You could also enable or disable recordings via role-based access controls. And that does give us a session recording, which we could play back. You'll be able to see when I logged in. Sweet. All right. That concludes the demo portion. I could go more in depth if we have any questions that are asked something more specific.
See here.
Thank you, Jay. We do have a few more questions in the queue. One of them is, what is our pricing model?
So it's, yeah, I'll take that one. Our pricing is a per user pricing model per protocol. So you basically determine how many users you need access on each protocol, and then we price it accordingly. And we our pricing is based on an annual basis.
Great, thank you. Got another question here in the queue. We already have passwordless authentication enabled with Ping. If we use Teleport, do we need any change in this?
So you could use Ping as your identity provider. So you could use Ping as your IDP, and you could bring Teleport as your role-based access controls. Wish I had a little more information as how you access the passwordless, but Teleport will be able to authenticate, use Ping as the authorization, and then Ping as the authentication, and Teleport does authorization, audit, and connectivity for you. There's the 4 pillars that we tackle.
Excellent, thank you. One more here on how are sessions being stored?
Good question. So depends how you deploy it. So we have several deployment models. We have our cloud offering. Our cloud offering Teleport hosts the proxy and the auth for you, which means we also store your session recordings in AWS S3. They're good for a year. We also have our on-prem offering, which is similar to the open source, where you're able to either store them on disk or store them on an S3 compatible client. So in AWS, you have S3. In Google, you have cloud storage. So you could store them on that, and you could set your own retention policies based on that information.
Thank you, Jay. One more question here is around what are the different deployment options that Teleport offers?
Okay, good. Kind of touch that. So yeah, the cloud offering, and then we have our on-prem. The on-prem deployment is really fast. You could deploy it. We have a Helm chart, so it can be deployed on Kubernetes. The Helm chart literally gets you started under 10 minutes. We also could deploy on the Linux host, or we have our cloud offering where we host it for you, and you're just responsible for connecting your resources.
Excellent, thank you. And with that, we've reached the end of our questions and the end of our presentation. We have one more question. If you can elaborate more on Teleport authorization capabilities such as RBAC, ABAC, PBAC, delegation of administration, scalability.
So yeah, Teleport uses RBAC, role-based access controls over attribute-based. If you have an identity provider like Okta, which does bring attributes, you could turn those attributes into things you can map to a label. So everything in Teleport is mapped using labels. So labels or tags, how other places call it. So you create labels or tags for all your resources. And based on those tags, you could grant access to users. So it's kind of complex, but it's a JSON, it's a YAML file, in essence, YAML. It accepts regex. You're able to do and or parameters. So you could go as deep as you want. So you could say a specific resource, you could say a specific set of resources. Additionally, anything in Teleport, any function of Teleport could be locked down via role-based access controls. So you could completely eliminate protocols from from engineers' site. You could also eliminate or approve ability to see audit logs, session recordings, modify teams, or trusted clusters. I didn't touch about trusted clusters, but trusted clusters essentially allows you to create multiple Teleport clusters and have them be able to communicate with one another. And you could reach resources across the aisle, but when the trust is established correctly with role-based access control.
Thank you, Jay. Just want to give maybe one more minute in case there are any other questions. One question that comes up often is also, what is the best way to get started with Teleport? So for those of us that are in the presentation now, what do you recommend?
Yeah, the easiest way is we have a 2-week free cloud trial. So if you go to our site, I don't know if you could get us a link there, Adelia, but essentially you could go to our site, set up a 2-week trial. All you need literally is an email address, no credit card required. And then other than that, if you want to go open source, we do have in our GitHub gravitation-teleport, we do have a directory called examples. Within examples, we have Helm charts, we have Helm chart examples and Terraform examples. Terraform is for AWS. So it's you get started that way.
Excellent. Thank you. And it looks like we've reached the end of our questions. I want to thank you everyone for joining us in this presentation today. And thank you to our presenters.
Thank you.
Thanks
you,
for
everybody.
having me. Can't believe you gave me a microphone.
Have a good day.
Thank you, everybody, for your time.